Good afternoon, geometry students. So today we are continuing in our lesson and we are talking about parallel lines and how they relate to triangles. So today I'd like for you to be able to use the triangle angle sum theorem and the triangle exterior angle theorem. And we're working in section 3-5 one more time. So the first thing that I want to introduce to you today is something called the parallel postulate. The parallel postulate is rather simple, and basically all it says is this: if you have a line and you have some point somewhere else, say point P, that's not on this line, then only one line can go through point P to be parallel to this one down here. So there is only one possible line going through point P that will be parallel to L. Our next theorem is called the triangle angle sum theorem, and it's possible that you've heard of this before, and all it states is that when you add up the insides or the angles of a triangle, they will always add up to 180 degrees. So here we have triangle ABC, and it says the measure of angle A plus the measure of angle B plus the measure of angle C is going to get me 180 degrees. So let's go ahead and put that into action. It says solve for all missing values in the given images. So here we just have a question mark. We have a regular triangle. We know two of the angles. We need to figure out the third. So I'm just going to label it X just so we have something to call it. And remember from our triangle angle sum theorem up here, A plus B plus C equals 180. Well, here, this angle plus this angle plus this angle must also equal 180. So I'm going to say 55 plus 82 plus x is equal to 180 degrees. Then I'm going to add 55 and 82, which is 137. And then I'm going to subtract it from both sides. And that gets me x is equal to 43 degrees. And then I'm done with that problem. So that was pretty quick. We just basically add them up and subtract them from 180. Over here, we're going to have to break this image up into kind of smaller triangles, and there's a lot of different strategies that you can use for this. So I'm just going to show you a strategy that I decided to use, but of course, if you see another way to solve this, then that's okay as well. So first, I'm going to start with letter X. The reason being is because I have this small triangle right here. And I know two of the angles in that triangle already. So I can say, oh, 30 plus 80 plus X has to equal 180 degrees because these three angles form one triangle. So that's how I'm going to solve for X first. So I'm going to say 30 plus 80 plus x is equal to 180. So that means 110 plus x is equal to 180. Subtract 110 from both sides, and I get x is equal to 70 degrees. Now I'm going to use this x equals 70 degrees. I'm going to go ahead and stick it in. Just write it in just so we can see it. And I can now use that to help me solve for more values. Here, I notice that x and y both form a line. X and y are a linear pair. Remember, a line equals 180 degrees. So instead of saying x plus y equals 180, I'm going to say 70 plus y equals 180 because I know that x equals 70 and I know that these two guys added together form a line. So here I have 70 plus y equals 180. Subtract 70 from both sides, and y is going to equal 110 degrees. And finally, I need to figure out z. So I'm going to put in the 110 right here for y. And now I have two strategies I could use. I could say, oh, this triangle right here on the right could be 40 plus 110 plus z equals 180. Or you could look at the big triangle, the whole triangle right here. And you could say, okay, so 80 plus 30 plus 40, because that's what this whole angle would be, and then plus z equals 180. It's whatever you choose. I'm going to do the one to the right because I feel like that one's simpler. So I'm going to say 40 plus 110 plus z is equal to 180. I'm running out of space. 40 plus 110 is 150. Subtract 150 from both sides, and I get z is equal to 30 degrees. And so now I've solved for x, y, and z, and I'm done with that problem as well. Flipping your note page over to the back, we now have something called the triangle exterior angle theorem. So notice how the titles are a little bit different. This one is just called the triangle angle sum theorem, while this one says triangle exterior angle theorem. So this is going to have something to do with the outside of the triangle. And what this is when you say elongate one of the sides of a triangle, like this or like this, the angle that gets formed with the elongated side is equal to the sum of the two remote interior angles. One more time. This angle on the outside is equal to the sum, or using addition, of the other two remote interior angles. The word remote basically just means far away, like the angles that are not part of angle 1. So we're not including this guy down here, we're including these guys over here. So let's go ahead and see an example of this in action, and I think it'll start making even more sense then. So here we have our triangle, and a side is extended, and we're trying to figure out what x is. Well, based off of our theorem from above, it says the exterior angle is equal to the sum of the two remote. So here I have my exterior angle x is equal to the sum of the two remote, which are 86 and 63. So all I have to do is say 86 plus 63, and I'm going to get x is equal to 149 degrees. And I'm done. That's all that was. I add the two remote angles and set them equal to the exterior. So problem B is very similar to that. I'm going to say 62 plus 64 is equal to E. Add those up, and I get 126 degrees is equal to E. Moving right along, we only have two more examples and then we're done. So this one for letter C is a little bit difficult because this time we are given the exterior angle. Because we're given the exterior angle, we are going to solve for one of the interior angles. But the setup of the problem is the same. This angle plus this one equals the exterior angle. So I'm just going to go ahead and just say E because there's no angle that could get confused with. So I'm going to say 40 plus E is equal to 117. Now I'm going to subtract 40 from both sides, and I get E is equal to 77 degrees. Final one. Here I'm going to try to solve for x, but what we need to do, we just need to keep consistent this formula that we've been given up here. The two remote interior angles add up to get me my exterior angle. So I am going to say down here 5x minus 10 plus 50, because that's the two interior angles, is equal to 9x minus 8. Now it's time to start solving like we would any other equation. So this is 5x plus 40 is equal to 9x minus 8. I'm going to add 8 to both sides, and that gets me 5x plus 48 is equal to 9x. Then I'm going to subtract 5x from both sides, and I have 48 is equal to 4x. And finally, I'm just going to divide by 4 on both sides, and I get x is equal to 12. And that's all it was asking for. So this is a pretty short video today because the theorems were kind of quick and simple and to the point. But of course, if you have questions, then make sure to bring them to me tomorrow in class. Have a good night.